Assalamu alaikum, bismillahirrahmanirrahim. So today we will start our ninth week lecture, lecture number 17 and 18. In the last lecture we have completed reverse Carnot cycle, and one of them is its numerical. Today we will revise all those, not all those, but refrigeration cycle with the practical application and with the practical machinery, so you can get the better concept of refrigeration cycle. So let's move on. uh, yes, this is the hmm, what is- yes. So this is PV diagram of Carnot cycle, and this is reverse Carnot cycle. From this picture you can easily see that in the Carnot cycle you getting heat from the high source and releasing in a heat sink, and in between the area under the curve, it is we get the power out of it. Okay. And the application of the Carnot cycle is IC engine, your motorcycle, car engine is derived from the Carnot cycle. And in reverse Carnot cycle it is opposite. You are removing heat from the lower temperature heat sink to the higher temperature heat reservoir, and to do that you need a special device called refrigerator or air condition air conditioner AC, that remove heat from the cold area towards the hot reservoir. And for that you need to give the power, not getting the power, oppositely you have to give power to do to perform that job. And all this process are in the reverse direction. In Carnot cycle it is a clockwise, and in reverse Carnot cycle is a anti-clockwise. So move on. These are the common things: refrigerant, compressor, heat exchanger, entropy. We discussed it before, and this cycle we also discussed before. Today we will study the actual machine working behind them. In the last lecture, I just played this video and explained the internal system of the refrigeration cycle, how it is working, and it is a schematic drawings, not an actual physical picture of the actual machine. So I just place the actual physical picture of the machine so you can get the better idea of that how the refrigeration circuit is working. Okay. So just repeat it. The compress why we are get how the first question in the refrigeration cycle, that how we can get the cooling effect. You can get the cooling effect by pushing high pressure to the lower pressure area. Like I give an example of a perfume. The perfume inside the body space, body deodorant, body spray, you have a high pressure liquid inside the vessel. When we press the button, the high pressurized fluid goes outside of the atmosphere, and that have a very low pressure as compared to the inside vessel, and due to that we have a cooling effect. And further, when the liquid is placed over our hand or our body, it has a volatile capability. The perfume evaporate in the environment, and due to the evaporation you also get the cooling effect. Same like here by the compressor you have a high pressure temperature refrigerant, and when we by the expansion valve or capillary tube we squeeze the volume and then place at a higher dia volume. So doing that the pressure will reduce. Okay. And due to the reduce of pressure, the refrigerant gets cooled down, and when the liquid cool down over here, it gets heat from the indoor surface or a refrigerated space or a indoor room, and gets boiled, and it's volatile, just like our body spray. So the perfume is spread over our body, it's evaporate in the environment, and then we get the cooling effect. Same is going over here. This liquid is boiling, it is evaporating and getting heat and absorbing heat from the environment and become a gas, and that gas again goes into the compressor by sucking it. It sucks the gas over here and discharge at the higher volume. And we also have discussed, sorry, yes, we also have discussed this TS diagram, that how the temperature is getting lower during the expansion process. Now the actual machine working behind it is compressor. You can see this is the compressor. Yes, the actual, if you open the outdoor unit of the AC, you get the compressor like that, like this. Okay, why it is played, yes, and it goes to the condenser, and you can see the outdoor unit of the AC, you have the heat exchanger like this. Air is passing from back side to front side by the means of the blower, and it's not, the temperature will not cool down. You getting my point? It condenser receive gases form of a refrigerant, and when it's extracting or releasing heat into the outside environment, the phase change process occurs. Okay, and when this goes into the expansion valve or capillary tube, you see the dia, the gas come over here with some of dia, and then the dia is squeezed down, and this is squeezed down, then goes to the higher dia volume of the evaporator. So from the low volume to high volume, the pressure will decrease, and due to the lower of pressure, the temperature also decrease, and further it blows cool down. The air is passing from this point to this point, and when the air passing from the evaporator, the air will also get cooled down, and the refrigerant inside this tube, why it is not get, I think due to the video problem, I cannot able to zoom out this thing. Okay, so the air is cooling from this point and getting, and again the refrigerant will not decrease its temperature, it will decrease in the expansion process. When the refrigerant comes into the evaporator, the phase change occurs again. The liquid refrigerant, again it is have a very volatile temperature. It volatile at 12 or 13 degrees. When the room temperature air passing with over here, it contact with the refrigerant with the temperature like room temperature 25, 26, 27. So the liquid refrigerant gets boiled or evaporate, and that evaporated refrigerant again goes back into the compressor. This is the cycle goes on in the same way. In the last lecture, we haven't discussed the ideal and the real vapor compression cycle. The refrigerant cycle, which is right now we are studying, it called vapor compression cycle, because it gets refrigerant effect with the by the help of vapor compression. Okay, so this is the ideal cycle. This is the compressor part. Compressor is increasing the temperature pressure of the gas. The condenser change the phase change from gases to liquid and release heat at the outdoor. And in the expansion valve, we have a lower dia and suddenly larger dia. So due to the decrease of pressure, it gets cooled down. And in the evaporator, the liquid refrigerant again takes heat and phase change process occurs. It evaporate and become a gas and then suck into the compressor, and the process like this. In the actual cycle, this is the ideal cycle, but in the actual cycle we cannot work under the dome. You know that compressor works only on the gases, not with the mixture of liquid and vapor. So we have to move this liquid towards the saturated vapor, and when it's completely evaporate, the evaporated gaseous form of the refrigerant goes into the compressor, and then compressor compresses the gas, and due to which the gas becomes superheated. It is not a water, so the temperature, even it is in superheated state, the temperature is like 70 or 80 degrees centigrade. Okay, not like a water more than 100. Okay, so when then heated refrigerant gas goes to the condenser. The first of all, it reduces the temperature of the refrigerant, and then it change the phase from the gases to liquid. And when it completely liquid form, then the expansion process occurs. In the expansion process, it in the ideal we have form a straight line, but in the real cycle it is not a straight line. It releases also, it changes phase from liquid to the mixture. In the real cycle, I have just this is another topic. We ended this topic over here just with the one video I got from the YouTube. I will also attach this video at the end of the. Yes, that's this is the process. Compressor gas. It is difficult to maintain the. Yes, you can see that the compressor is the refrigerant gas by high temperature pressure is go to the condenser, then in the by means of expansion valve or capillary tube. I've discussed I also show the capillary tube action. Now there's another device called thermostatic expansion valve. Both can be placed in the fridges. You can see that the capillary tube, but if you go towards the higher chiller, like chiller or a big floor standing unit, you will see that the expansion valve, the working principle is all same, but thermostatic expansion valve is advanced. It can control the flow of the volume with reference to the temperature of condenser. If the condenser temperature goes high, it means that the temperature it getting very much heat, so it open the 100% valve open. And when the temperature becomes normal of the room, you won't get the very high temperature gas in the evaporator. So volume, that expansion valve restrict the volume, and by the means of by means of expansion valve, you have a control flow of refrigerant. So these are the expansion valve. Let's go towards the. Yes. Yes. Inside the expansion valve, this process going again. The liquid from the condenser, when passed from the expansion valve, it is sprayed in the evaporator line, and when it is sprayed liquid, it becomes a mixture of liquid and refrigerant, like an ideal cycle, like the picture over here I've shown with the. Yes, you see that it is not going over here. The liquid in the expansion valve, when it is spray 100% liquid into the evaporator coil, temperature gets lower, and in the form of mixture of liquid and vapor, and then in evaporator it gets heat and changes from liquid to mixture to 100% gas state. Okay. Yes, this is liquid coming from the condenser. When in the expansion valve, it is spray like this and gets cooled down. This is the valve, and it is sensing from the condenser line. If the evaporator line, if the evaporator temperature is higher, the expansion valve fully opens, and it's when it goes into the normal or set temperature, like if you set the temperature like 22, when the temperature of evaporator is not getting very much high or not absorbing heat from the environment, the the gases in the bulb sensing bulb gets lower temperature pressure, so it closes down this valve and it adjusts the flow of refrigerant. Okay, I hope you understand this video, and I also upload if I get the time, I also upload the real picture of indoor and outdoor of air condition AC. If I get opportunity to go in the workshop, I will upload its video. When I just teaching a physical class, I used to cover or used to have a lab session of all students where they can see the actual machine of a air condition, how it's working. But right now, due to the pandemic condition of COVID, all of the students cannot go to the lab, so I just upload that video, physical video, so your concept becomes more clear. Anyway, let's move towards our second topic. Yes, I hope I have understand this. Okay, so after that we have covered the reverse Carnot cycle, and in the now we are going towards the heat and mass transfer topic, the second portion of basic mechanical engineering. And after that we will go towards the I should open the camera. Yes, after that we will go towards the HVAC system. In HVAC system, we already studied lot of basic devices like refrigerator in the thermodynamics, in reverse Carnot cycle, the ideal heat pumps. So all that machine we will discuss in the detail standard form in HVAC. And even in HVAC, there is a lot of common terminologies that has been discussed or learned in the thermodynamics, and as well as the heat and mass transfer. Okay, so before learning or covering HVAC, we have to cover heat and mass transfer, and after that we will go towards the heat and mass transfer. Okay, so I stick this lecture. Okay, now we can start. Okay, so we stick this lecture here in the next lecture, in lecture number 18. It is a long lecture, and we will cover heat and mass transfer topic in a one lecture video. Okay, till then, Khuda Hafiz. We will see in the lecture number 18. Khuda Hafiz.